Okay, so today I am going to review what I call vertex form of a parabola. And the first thing we have to understand about vertex form is that this section here on the top where it says y equals x plus 3 quantity squared minus 5, the first section I'm going to refer to it as my slide. The second part is going to be reserved and called the shift. Now, this object always slides in the opposite direction. Therefore, if it says positive, we are actually going to slide the object over to the left. The shift, on the other hand, follows instructions. So instead of moving the opposite direction, I'm actually going to shift down. Therefore, this is the position. Based on this, my position of my vertex is going to be at -3, -5. And this is going to represent what I have in the past referred to as the vertex. So I come to my graph, I find where y is, I find where x is on the positive side, I have the negative, I have the negative, and this is the position of the origin. So from the origin, I am going to move across the way 3 spaces. So 1, 2, 3, and down 5. 1, 2, 3, 4, 5. Now, this is now going to represent the position of the vertex. Now, what I'm going to do is I'm going to put that value of -3 and -5, and I'm going to place it in my t-chart right here. I want to be able to see that I have the vertex in my graph, and I want to be able to see what the vertex looks like on my t-chart. Now, here's the convenient thing. Because of the skip counting that I'm going to follow, what ends up happening here is that from this, if I were to go backwards, I would actually, if I go forwards, this would be -2, -1, 0. That's my pattern. Okay. 0, -1, -2, -3 becomes -4, -5, -6. And then what I'm going to do is I'm going to remind you that this pattern always has odd numbers for the skip counting, meaning it's going to count by 1, by 3, by 5. Now that I'll take advantage of in my picture, and that is 1 and over. This is 3 and over. This is 5, 2, 3, 4, 5, and over. So what that means is I'm going to have a point here, here, and here. Now, once I have that, let me not forget that as soon as I have my vertex, I should also be thinking of the position of my axis of symmetry. So my axis of symmetry will be located right here where the vertex touches. And let's make that green, I guess. I'm just going to cut right down. And so what this gives me is what I'm going to commonly refer to as my axis of symmetry. Now, the reason that that is useful is because if I have my axis of symmetry and I notice that I have a point that is 1 space away, then I can do the same thing on the opposite side. Okay. If I notice that the next point is 2 steps away, then I can now do the same thing on the opposite side. 2 spaces away. And by the time I get to the third one, that is 3 spaces away. This now gives me all the information I need to create what I will simply call my positive parabola. And it will look something like this. Okay. And this is still a positive parabola. Right, so how does this skip counting on my graph affect my t-chart? Very simple. If I start with -5 and I add 1, I end up at -4. If I have -4 and I add 3, I end up at -1. -1 and 5 makes 4. Now, the thing about it is that if I check that and I happen to go to -2, -4, that means that from the origin, I would go -2 down 4. I'd end up right in this space. The next one is -1, -1. I'd end up right there. And the last one, 0, 4, which ends up right here. All that together means that I have graphed these points in the right spot. Now, because of this axis of symmetry idea, if I notice that -3, -5 is my vertex, and that is my vertex, then the cool thing about that is that on the other side, on the negative side, it's going to just repeat. So -4, -1, +4. My skip counting, if I show it, would have said -1, -3, -5. And I can easily check because 4 take away 5 is -1. -1 and -3 does make -4. -4 and -1 does make -5. So all of that works. Next, I'm going to convert my vertex form, which is my original equation, and I'm going to change it into something that I refer to as standard form. So to do that, I'm going to start by taking the square, and I'm going to go ahead and write that out here. X plus 3, x plus 3. That's the square part. The -5, I'm going to purposely put that on the side. Now this is nothing more than a big old times tables. So when I do the multiplication, x times x will give me x to the second power, x squared. X times 3 will make 3x multiplied. 3 times x is also 3x. And 3 times 3 is 9. Once I do this, I purposely break this up into 3 sections by circling the 2 pieces in the middle. And I point out that, in a sense, the symbol in the middle tells me exactly what to do, which is to add those 2 pieces together. With that, my conclusion will say that I now have y equals x squared. 3 and 3 make 6, so plus 6x. And 9 minus 5 makes 4, so that's a positive. I refer to this rule as my standard form. Okay? So just to clarify, this equation here on the top original is called vertex form. Mostly because it gives you the position of the vertex. This equation here is going to be called standard form. And this gives me separate information. The information that it gives me is going to be labeled as some information called A, B, and C. Now, A represents the number that would be in front of the x squared. Since I don't see it, I automatically assume that that's a 1. B is always the middle number. In this case, it happens to be 6. And C is the last number, which happens to be 4. Now, the cool thing about these numbers is that they actually show up on the grid just the same way as the vertex, but in a different form. So the first thing I want you to notice is that C is always going to represent my y-intercept. Okay, so that means that up here, this particular point is C. And I know that because from the origin, I go straight up, and that's 1, 2, 3, 4. So this is C equals 4. As soon as I know where C is, I purposely go across the way. Let me change it up a little bit. I purposely go and I go across the way. Let me undo that. I don't like that color. So what I end up there is, let me do it this way. Let's see if this is any better. And I go across the way here. And it turns out that that space is a total of 1, 2, 3, 4, 5, 6. So then B is equal to 6. But if you think of this as a slide, it's sliding in the opposite direction. It's sliding in the negative. So slide is always the opposite. So this becomes a positive 6. And then the A, so here for B equals 6, I'm going to purposely put an arrow that goes in the opposite direction. And on purpose, A equals 1. Well, that's the original number that I am doing my skip counting by. So that's my original 1 right there. Here would have been 3, here would have been 5. Okay. And that's the basic information in terms of how to solve this. Okay. Now I'll go over one more to kind of go through the information. Just to see whether or not we can make more sense of this. Okay. So think of this as your second example. And this is still going to be the slide, and this is still going to be the shift. This particular slide is the opposite of negative, so it's going to go this way. And this is a -6, so it's going to shift down. That means that my vertex is going to be at +1, -6. If I go to my graph, I find the position of the origin, and that would be +1, 1, 2, 3, 4, 5, 6. And then this would be the position of my vertex. Which I'm now going to put here in the middle. And just like before, I'll do my skip counting. 1, 3, 5. And at the same time, from the position of my new vertex, I will go ahead and create my axis of symmetry. So this is now my axis of symmetry. Okay. Since my skip counting is going to be a 1, a 3, and a 5, I have a 1, a 3, and a 5, I'm going to take advantage of that here on my picture. So that means 1, 3, and 5. 2, 3, 4, 5. It always gets wider by 1. So I have a point here, here, and here. Because of symmetry, I can repeat it on this side. this side and on this side. That now creates for me a parabola that will look something like this, and the mirror image on the opposite side. Because of skip counting, I can probably play with the numbers and say that this is going to be a -5, this would be a -2, and this would be a 3. This is going to be 1, 2, 3, 4, 0, -1, -2. Okay. So this is how I manipulate it. Notice that this T-chart is different than the one before because my vertex is in a different spot. So if I scroll down a little bit, you'll notice that my original vertex, my new vertex happens to be at 1, -6. And so that determined the counting. My original one was a -3, -5. And so it had a different count. Okay? Just kind of be aware of that. I'm going to basically say that I still have the mirror image. So that means this has to be -5. This has to be -2. And this is still 3. Okay. Now, much the same way as before, it turns out that from this position, this is C. And if I go across, this is B at -2, the opposite slide. So I can suggest that A equals 1, B equals -2, and C is equal to 1, 2, 3, 4, 5, -5. Now, if you notice, I'm giving you the values for standard form before I even solve it. So now I'm going to prove that these answers are correct based on my picture. So in here, I'm going to put x take away 1, x take away 1, and the -6 is on the side. Now the x minus 1 is my square. That's why it goes attached to the square. The -6, which is the shift, is on the side. That's why it ends up on the side. In here, I have now x squared, -1 times x, -1 times x, and a +1 answer. That now produces y is equal to, remember, I'm going to go ahead and break this into sections. So now I'm going to say that I have x squared, -1 plus -1, as far as the x values are concerned, is going to be a -2x, and 1 minus 6 is a -5. So with that, I can confirm that A is 1, B is -2, C is -5. Okay. All of the questions for vertex form changing into standard form are pretty much the same way. My T-chart is there to adapt to whatever the new position is. I'm going to be adding more lessons like this, mostly as review, and feel free to use this as part of your work. All right.